Welcome to the first episode of Painting with Organic Chemistry, the common way to learn. For this session, we're going to learn how to name alkanes. Naming molecules can get extremely complex, so we're going to cover the high-level rules to get you started. In the simplest terms, alkanes are hydrocarbons that only have carbon-carbon single bonds. Let's first apply a nice calming blue background. We want to be relaxed when we're doing organic chemistry. So I'm going to use a wide brush, and let's go with watercolor, nice light blue, use nice even strokes, fill in some of the edges here. There we go. So if you just have a straight zigzag line, you can easily name the molecule. All alkanes have an ane ending and are named according to the number of carbon atoms they contain. This, for example, is pentane with 5 carbons. In this chart, you can see the names for alkanes with up to 10 carbons. If the molecule is more complex, there's a process to go through. Let's paint this molecule, for example. We'll use some nice brush strokes, get it nice and established. There we go. First, you want to identify the parent chain. That's the longest continuous chain of carbons in the molecule. Sometimes it's a process of trial and error, and sometimes it can be very easy to see this in the molecule. First, I'll count this way. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. This seems to be the longest. But if I count this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, this one also has 9 carbons. To decide which one to classify as the parent, you pick the one with more substituents coming off it. Substituents are the groups attached to the parent molecule. If I go this way, this chain has this big substituent group on it and the methyl, so 2 substituents. If I go this way, this one has 3 substituent groups, so it wins out as the parent chain. Once you've established your parent chain, you need to name your substituents. These have the same prefixes as the parent chain, but the ending of the word is -il instead of -ane. So here our substituent has 2 carbons, so it's ethyl, and here our substituent has 4 carbons, so it's butyl, and this last one has just 1 carbon, so it's methyl. The next step is to assign numbers to the carbons on the parent chain. Once we have these, we'll be able to assign a number known as a locant to each substituent. We want these locants to be as low as possible, so in this molecule we face a choice. Do we start numbering from here, where the ethyl group would be on carbon 3, or do we start from here, where the methyl group will be on carbon 4? This way wins out. The substituent is on the lower carbon number. So we have 3 ethyl, 5 butyl, and 6 methyl. The next step is to put these all together to form our molecule name. Arrange the substituents alphabetically. The numbers don't affect their placement in the name. So we have 5 butyl, 3 ethyl, 6 methyl nonane. Let's paint another example. Okay, that looks good. In this situation, we see 2 substituents that could both potentially be on the carbon 2. When this happens, look at the number of the next substituent. The option that numbers this substituent with a lower number breaks the tie in this case. In this case, the ethyl group will be on carbon 3 if we count from the right, instead of carbon 6 if we count from the left. So this way of numbering wins out. We identify our substituents. Here there are 2 methyls on the same carbon, so you write the number 2 twice to denote that. We then see there's another methyl on carbon 7, so there's 3 methyl groups total. And then we have an ethyl group here on carbon 3. Now we have to alphabetize. You do it based on the original word, not on the prefix used to denote how many of these substituents that there are. So in this case, the E in ethyl comes before the M in methyl. We don't take the T from trimethyl into account. So this molecule is 3-ethyl 2,2,7 trimethyl octane.